My name's Andy Zepp. I'm Executive Director of the Finger Lakes Land Trust. And for those who may not be entirely familiar, we've been around for more than 30 years. And of the 26,000 acres we protected, a lot of that land was targeted for water quality purposes. So we have a long tradition of focusing on water quality. But about 4 years ago, with the outbreaks of toxic algae, we really redoubled our efforts. And since then, have expanded our work relative to water quality. We're working with lake associations, many who are represented on this Zoom, soil and water conservation districts, the U.S. Fish and Wildlife Service, and DEC. So as we continue to do that traditional land conservation work, we're also getting into restoring streams and wetlands and vernal pools and looking at detention basins and planting forest buffers and fighting off deer that eat forest buffers. And also we recognize that we're learning a lot and we want to share what we're learning. So hence tonight's program, and we hope will be a series in the future, because I've been really fortunate to learn from Professor Rebecca Schneider, who is an associate professor at Cornell, who has a diverse array of research interests, but in particular tonight, she's agreed to share her insights and what she's learned as she looks at how road ditch networks affect water quality and what are some of the ways we can mitigate those impacts. And what I've particularly enjoyed getting to know Rebecca is not only is she an excellent scientist, but she has the on-the-ground knowledge of being a planning board member for the mighty town of Ulysses. So she's grounded in the reality of what we have to do on the day-to-day in dealing with these ditch networks. So Rebecca, thanks so much for joining us this evening.
Great, thanks so much. I'm going to share my screen. Okay, everybody can see that, I hope, to take up your full screen. All right, well, first, it's a real pleasure and an honor to be here. I really appreciate the opportunity to get to work with Andy Zepp and Kelly and the entire Finger Lakes Land Trust team. They do amazing things, and I feel very lucky. Okay, so I'm going to start. Oh, wait, let me give you I jumped up too fast. All right. Briefly, this is how I've organized the talk. And so you just have a sense of where we're going. And there's a couple waypoints that'll keep us on track. So I put this in the context of climate change. Then I'm going to give this basic watershed hydrologic framework that I give at the beginning of every talk, even if it helps ground everybody and give us the same foundation. Then I'll tell you about our roadside ditch research findings, the main things we've come up with over the years, and what we've done with outreach, some of the successes, and you'll hear some of the challenges, and then some new approaches, some new things. So I recognize some faces in the audience. So if you've been following our ditch work, about half of this may sound pretty familiar, but I hope you'll learn some new things towards the end. Okay, I'm going to start by putting this work in the context of global warming. Global warming is intensifying our climate with more frequent and stronger extreme events. And these changes are already manifesting as an increase in the frequency and magnitude of high intensity rainfalls, torrential downpours, right? And that translates to more flooding. So this is happening in the Northeast United States over the past 116 years. There's been a 38% increase in intense events. And we even experience it in New York State. So for example, in New York in August of 2014, more than 1 foot of rain fell in less than 24 hours, which is incredible to even think about. All right, it broke a record. And these are the kind of events that are occurring. There is also more frequent and more intense droughts, and parts like the southeastern United States have had really intense droughts, but we've also had some. So while California was experiencing a drought in 2016, New York and Tompkins County was also experiencing an extensive drought, and it affects our ability to grow crops. It affects everything we do. So for this context, the ultimate solution is we really need to deal with reducing greenhouse gas emissions to get the climate under control, to reduce the rate of heating of the total atmosphere. That's going to have to take a whole global international effort. But in the meantime, our communities are being impacted, and we need adaptive strategies that make them more resilient. So for example, these are photographs taken of the Endicott sewage treatment plant along the Savannah River, about 50 miles south of Ithaca, where I'm located. And that's what it looked like in the flood of June 2006. And then just 5 years later, it was flooded again. These are huge flood events. It cost millions of dollars. And there were people in communities all along the Susquehanna River that also were flooded, and businesses. So we need strategies to deal with this. All right, the basic watershed hydrologic framework. Yeah, you have to understand, in order to deal with floods and droughts and all the associated water pollution, you got to understand what's causing this. All right. So I always start with these same few slides. The processes of flooding and droughts happening within watersheds. The watershed is the bowl that captures rainfall. All right. The lip of the bowl is the surrounding hills. The bowl determines how much rainfall you get. It's relatively limited. It's a knowable amount of rain. And historically, before people understood the concepts of the watershed, they didn't know. Rain just kind of fell and you didn't know what you had to work with. And we managed water based on political boundaries. The watershed also determines the pathways that the water makes as it passes through the watershed. And basically, it's one of two pathways in the eastern United States. If the substrate or the surface is relatively hard or impervious, or when it rains, the water hits that and it runs off pretty quickly. It's the surface runoff and then the water in the shallow zone beneath it, and it moves pretty quickly down to the streams and rivers and ultimately to the ocean. But if the soil is very permeable with lots of pore spaces and it's kind of got organic matter that acts like a sponge, then the water infiltrates into the ground, it percolates down until it hits a hard layer like bedrock. And then it fills up all the pores, and that's groundwater. And that also moves sideways down to streams and rivers and ultimately to the ocean. All right. Those are the main two pathways. And since you only get a certain amount of rainfall, it's a balance. It either goes one way or the other. The last part of the hydrologic cycle is the evapotranspiration. And out in the West, that's a huge piece. But in the Eastern US, we basically work with those first two parts. All right, let's start with the runoff element. That's the water that flows through the stream channel network, and those streams come together to form our larger rivers. All right, and this is just a photo of what a stream channel network looks like by Arthur Bertrand, and there's the hills that make up the lip of the bowl. And this is just looking down. Here's the watershed divide, and there's the tributary network, and our runoff moves through the stream river systems. All right. We all know that streams and rivers naturally fluctuate in depth and in how much water they flow through them. This plot is called a hydrograph, and on the horizontal x-axis is the date, and this is 1 week of time, and on the vertical axis is the water depth in the stream or river. And what you see is there's the water level in the river, and then it rains and very quickly rises. This is the runoff piece. That's the quick part that moves quickly to the stream. Then it gradually starts to subside and it's not raining anymore. So the water is still in the stream. That's our groundwater piece that got there slower. And it depends where you are and how much rain, but that can go on for days, for weeks, or for months. All right. Groundwater is a key part of our streams. The USGS has estimated that across the US, on average, 54% of the water flowing in streams and rivers is groundwater. And so I just put two photos. There it is. There's the runoff piece during snow melt. There's this tree right here the arrow is pointing to. And here's the same stream with the arrow pointing to the same location, and the water is lower. So we all know water level rises and falls. Well, prior to European colonization of the United States, much of the northeastern United States was forested. It had rich organic soils, and many elements in the landscape helped to intercept rainfall, to slow it down, and facilitate infiltration of rain into the soil and down to the groundwater. So in this little schematic here, most of the water used to go into the groundwater, and the runoff was relatively a small piece. All right, post-development, our landscapes have changed drastically. All right, we took down the forests, many of the plants were removed from alongside stream sides, and we replaced them with buildings, rooftops, roads, impermeable surfaces. And we even took the soil that used to have a lot of organic matter and we kind of eroded that away and compacted the soil. So what happens is we've shifted the balance. So very little water goes underground. Most is moving as runoff now. All right. Now the faster part. Okay, so as a result, our hydrograph has changed. So what you see here is time down here in hours and days and weeks. Here's the rise of the water during pre-development condition. It would rise slowly during a rain event, hold steady, and then gently come back down, and there's still water in the stream. We've shifted that balance. So there's so much runoff now that now when it rains, the water rises rapidly. It goes way high. That's the flood events we're experiencing in our rivers and streams. Then it drops. And over here, it drops to zero. So we have rivers and streams that used to be perennial, even it's in the 70s. You can see this change in our topographic maps, the USGS maps, and they're now dry. And that's because we took all the water that would have gone down into groundwater and shifted it into runoff. And that water, and it's a balance. You only get so much. So the good news is that's kind of the good news. We did that. We have done so much to our landscapes that we're contributing and causing the floods and the droughts. Okay. So overall, we need an approach where we start to restore the landscapes, enhancing the ability to reduce runoff and increase groundwater infiltration. We need to shift the balance back. We can do this. This is the good news, guys. This is very doable. We're starting to recognize this and do it with things like green infrastructure. And that photograph on the left is like a little infiltration basin or a rain garden next to the road that captures the road runoff and the water goes underground. We're recognizing this through EPA phase 2 stormwater regulations. More needs to be done. It's critical to protect the overall landscape. We need to protect forests, wetlands, and the Finger Lakes Land Trust is doing a great job of this, along with other groups. They're thinking about the big picture, the broader landscape. FLLT is building continuous corridors of green space that have multiple benefits for wildlife, for recreation, and for water. That's their map on the lower corner of places they're protecting so that we have a green space to like absorb water. We don't think much about it, but it goes underground. With unusual foresight, California has passed legislation in the past 2 years that makes watersheds a legal part of the water infrastructure for cities. So that means if you want clean water, they go, we know you have to protect the forest. We can get funding under infrastructure, not just to replace pipes and put in dams, but to buy land so that we know we will have clean water. They're unusual in having done that. We need to think about that as an option. I want to add one key caveat. All these strategies are great. They will not be enough to deal with the torrential large downpours like that 14 inches I talked about, or 30 inches in Texas a year ago, or about 28 inches in North Carolina. When the rain is coming down at that intensity and quantity, the soil can't absorb it fast enough. You're going to have flooding. Rivers are adapted to flooding, all right? If we don't enclose them in levees, they move around naturally, all right? And the best example I can find is this historic map of all the meanders of where the Mississippi used to be. All those different curves on there is what the Mississippi used to do before we tried to trap it inside these levees, all right? Trees, plants, fish, the plants in the riparian zone are all adapted to deal with a dynamic environment. They will do fine. So the important part is it's going to be worse. We're going to have more floods. We need to move people and infrastructure out of the way, and as entire communities, not one little piece at a time, and reduce their vulnerability. And the photo on the right is terrifying to me. There's a young man next to a levee, next to the Chenango River in southern New York, and it's spilling over. I mean, the amount of water behind that little thin concrete is terrifying in terms of what would happen if it broke. We need to get people and reduce their vulnerability. The riparian floodplains can handle it. Okay, that's the framework to understand everything I'm now going to tell you about roadside ditches. All right. All right, this is a piece that was pretty under-recognized actually until we got involved about 20 years ago. I found the first poster we gave was in 2004, so we've been doing this for a while. I'm going to briefly explain our general research approach and then summarize our main findings over about the past decade and a half. I think about, based on, I glanced at names of people there, I think about a quarter of you or maybe even a third of you have seen this work in various forms along the way. I'm not going to belabor the details. And if anybody is interested in hearing all the details about any part, email me. I can give you fact sheets and papers. I'll talk to you about it. And then I'm going to show you our approaches to management and what we have been working on more recently. So when we started, the question was, here are these depressions next to every road. And they're everywhere you look. And we all take them for granted. We grew up with these. We've been doing this for 100 years. What role do they play in floods and droughts and water pollution? And that is the particular interest in for this particular talk. Okay. We've now worked, I think, in 14 different watersheds, mainly in central New York, where we've worked in 2 now down in Pennsylvania, and we actually are working in Indonesia. And we generally start in almost every study using the same approaches. The first thing we do is map the ditches. You need to know where they are and where they go. And do they connect to streams, or do they drop into wetlands or fields? And how are they being managed? Are there rocks in the bottom? Are there plants growing in there? Then we monitor whatever our research question is. We monitor usually the total water flow through, and it happens during storms. So we have these automated water samplers that can turn on automatically when a storm begins. And then we monitor things like suspended sediment and dissolved chemicals, fecal coliforms. And sometimes we look at what bounces on the bottom. And then we sometimes do some modeling. All right. We have 10 main findings so far. The first one is there are many miles of ditches in every watershed. All right. They actually, about 3/4 of those dumps directly into the streams. On average, there's about 94 places where ditches dump into streams in every watershed. That's 42 square kilometers, which is about 15 square miles. Right. These connections to the stream effectively increase the length of the streams by 2 to 4-fold. And that increases the connectivity between what happens on the land and what happens in our streams, rivers, and our lakes. And the top is a map of the mapping of the road ditches, and below it is the streams plus the ditches superimposed on top. And you can just see it's way more textured when you have these ditches intersecting the streams. All right. Road surfaces only cover 1% of every one of these watersheds. It's a very small percentage. That's why we don't think much about them. But the basins that drain downslope to the ditches are another whole nother thing. So in this picture on the left, this is a topo map. So these are a hill that's draining down to this stream over here. This is actually Salmon Creek. And what you see is the road, Lansingville Road. And this hill up here looks like this one. It all drains down to a ditch. And that ditch captures the runoff and also the shallow subsurface flow and shunts it all the way down. There's 1.63 kilometers down to this community right here. Normally that water would go down this hill and all along it and then enter the river, the stream down here. And that stream would have water entering it all along its path. Instead, that water's been intercepted, shunted, and this community was having severe problems with flooding, and they dealt with by actually diverting all that water into a large infiltration basin that is now right down here. And that solved the flooding problem. Meanwhile, the stream, of course, has lost that water that used to enter it right along here. So that's 22% on average of the water in every basin. Basically, like a quarter of all the water gets grabbed by a ditch and shunted somewhere else. Okay. This interconnection of all the ditches with the streams makes it much faster for water to move through the landscape. It decreases the travel time from the headwaters, upper part of the hill, the lip of the bowl, all the way down to the stream. Okay. Now, I want to start here. Lots of students and faculty and professionals have been collaborators on this work over the years. I'm not going to name them all, but I've tried to include them on the slide. This work I've been showing here is by Dr. Brian Buchanan, who was our PhD student several years ago, and Dr. Todd Walter, who's a faculty at Cornell. And the photo on the right is showing you a sediment plume, and that's coming out of a ditch into this stream. All right. All of this water converging rapidly in the stream translates into a rapid increase in the magnitude of the flow, i.e. a flood. So in this figure on the left, there's the stream coming down. All right, there's the road going across, and there's a ditch coming in. And Brian, as part of his dissertation, actually monitored 9 different sets like this. And this is what you see. This is a hydrograph, which I just explained to you. This is now ours. It's a storm event. This is how much water is flowing. And the little blue line is how much is carried in the stream. And then the ditch comes in. All right, so there's the blue line saying, oh, it's 0.02, that's cubic meters per second. It's a certain amount of water. The green is right when the ditch comes in, that's how much it brings. And now this is what this stream is carrying. It's increased the flow in the stream 300%. That's a flood, okay? On average, in his study, the ditches increased the flow by 78% and total flows by 57%. So the ditches contribute to flooding in our streams. Right. This large volume of fast-moving water enters the stream, and what happens is a small stream to a giant stream for a short amount of time. But all that power scours out the stream below where the confluence is. So here's a first order stream that is about 1.5 meters. That's about 4 feet wide. And it's flowing down. And here's two ditches that come in, and there's the road and the bridge, and the stream goes under the bridge. You stand on the bridge and look upstream, and this is what you see. And you turn around and look downstream, and this is what you see. Less than 20 feet. And this is 12 feet wide down here, 4 feet wide up there. And this is about 5.5 to 6 feet deep. It scoured all this entire stream bed out, right? So we're working with U.S. Forest Service to think about ways to manipulate ditches to restore streams in the Finger Lakes National Forest, because this amount of erosion, fish can't live in there. It no longer can, it only is flooded during the storms, when the ditches bring in all the water. So it's affecting the biodiversity in their stream systems. The ditches themselves are a source of sediment if they are scraped by the highway staff. So we're going to hear some statistics, but basically scraping is one way that ditches are managed to make sure that water flows through them. Now remember, highway guys have the job of making sure we get to work, that roads are clear in the winter. It takes a ton of effort. And ditches have always been associated with the road. The road is crowned, so the water runs into the ditch in a way so that it doesn't get flooded. And in the north, it also doesn't allow the road bed under the road to freeze. So they scrape these ditches to keep them clean. The problem is, the more exposed the substrate, the more sediment moves through the ditch. It's a source of sediment. The ditches are also conduits. So they're a source, but also they're a mechanism of transport of contaminants from adjacent land uses. So this is a farm field, a very extensive farm field. It had no cover crops. This is a storm event. And what you're watching is the sediment washing off into the ditch. It's moving towards the upper left of this corner of this photo. And that right there is the stream where those trees are, right? That's what you're looking at right here. Here's this clean stream. Here's that sediment in that ditch. And there it is joining the stream from both sides. And then it goes under the road and continues on down. All this sediment enters the stream and it's coming right from this farm field. Other things that move, so sediment carries phosphorus bound to it. De-icer salts from the roads go in there. All kinds of contaminants, and we'll talk some more about that. All right, we studied several ditches adjacent to farm field where manure was being spread, and we were really interested in whether there were living fecal coliforms or E. coli that were moving off. This was done with Kim Falbo McGarry and Dr. Dan Buckley. We were lucky the farmers were willing to work with us and would tell us when they spread. And what you're seeing is this is from 2008 through 2009. This is E. coli concentration on the y-axis. There's an EPA standard way down here, this red line. And what you see is 25,000 counts per 100 mils. It's way above the standard. And when they spread manure, the E. coli that we observed in the ditch spiked. And then it continued to be present in the ditch during rain events thereafter for months. These are living E. coli. And it gradually dropped down until we got through winter and they spread again and the cycle started over again. So the ditches aren't just moving sediments or chemicals, but living fecal coliforms, things we're concerned about. And they move so quickly into the ditch and then to the stream and down into our drinking water systems, and they're viable and they're moving into our systems very rapidly. Okay, we monitored 2 ditches and over 3 years for dissolved nitrate, plus a control ditch that had a forest next to it. And one of the ditches, they were spreading manure. And we found concentration of dissolved nitrate. Now, I don't know if you know much about dissolved nitrate. It's in a lot of fertilizers. It's in our septics. There's a limit on how much can be in drinking water of 10 milligrams per liter. Above that, it causes problems with something called blue baby syndrome. They have trouble breathing. So we don't want excess amounts of nitrate in our drinking water. And it's also what causes pollution in our estuaries and bays because it's a limiting factor and causes algal blooms down there. So we're very concerned about nitrate. We found concentrations in the ditches next to where manure was spread from 5 to 38 milligrams per liter. And so what you're seeing here is this is the watershed we studied. These two little green are just little tiny pieces of the watershed that drain to ditches. All right. We monitored stream flow before the ditches entered, right before this ditch entered, then after that ditch. This is the stream we're monitoring along with the ditches. And these are the flows. This is actually how much water is flowing. And what you're seeing over here, these are the concentrations of nitrate in this stream itself. Okay. And so it's very low, less than 0.5 milligrams per liter before these ditches enter. As soon as these ditches enter, the whole stream jumps up. These two ditches alone were dumping in on the order of about 100 pounds of nitrate per week or more throughout the summer. So huge amounts of nitrate affecting the concentrations in the system. We looked at whether the substrates in the ditches could get rid of that, filter it out through a process called denitrification. And denitrification is where bacteria that live in the soil take the nitrate, chew it up, and turn it into nitrogen gas that goes into the atmosphere and filter it out, which is a great process. It happens in wetlands and next to streams. It's the way we kind of count on getting rid of nitrate that we've dumped in the landscape. This process of denitrification puts out gases. So there's techniques to measure these gases. We worked on our, Dr. Roxana Marino and I worked on this in our agricultural site. And then Dr. Laura McPhillips evaluated in ditches next to like lawns. And there is definitely denitrification. It varies through time. It varies on whether the substrates are moist. It may be important, not when there's really low background levels of nitrate moving through the ditches. In our case, where we had such incredible quantities moving by, the denitrification in that case could not really touch it. Okay. That is a quick summary of the 10 main findings of tons of people's work over many years. Again, it takes a lot of time, 2 to 3 years to collect data, to process samples, to do data analysis, to write it up. People get their thesis out of it and careers out of it. And we've come a long way. All right. So what have we done with that information? All right. Now, this is where we are on our outreach. First of all, what we're trying to do is change practices that have been in place for almost a century. This is a photo I found. I was so psyched. And there's a ditch next to the road from almost 100 years ago. And they've always been taken for granted. And highway staff who work super hard and have plenty to do just trying to keep roads going are not really part and have not been part of this water resource conversation. All right. So they have not really been brought into, hey, we also need to think about flooding and pollution. So to bring people's attention to this issue, we have created and distributed hundreds of fact sheets. Dr. David Orr is the director of the Cornell Local Roads Program, who's an extension mission, and they work with all 1,000 highway staffs across the state. If you want to know somebody's name, ask David. He'll know who the highway guy is, everything about how they work. He works with everybody. And so we've distributed tons of fact sheets. We have several coming out now soon, but we've been working, we put this one out on dealing with downpours. Don't dig a deeper ditch. So highway guys, because of all these big intensity rains, are digging deeper, the ditches deeper, thinking that'll take care of the water. Well, they're unsafe, they erode, but they also capture more water deeper down in the soil profile. Now more water's coming in. So now it becomes more erosive and the ditches are now moving more sediment. It's not the right solution. We have given workshops and presentations, and I've lost count now. It's more than 100, I'm sure, to more than 3,500 town highway staff, natural resource professionals, government officials. The Cornell Local Roads Program is pretty much taking over much of the extension on this. They have a lot of their workshops directed around it, reaching out to highway guys to talk to them about what do we do about better ditch management. So what are we saying we can do? What do we need to do to change the management? And there's two overarching approaches. The first one relates to reducing the flooding. And it's simple. It's simple, guys. If we disconnect the ditches from the stream, it's just redivert them. The stream doesn't flood. In fact, if you direct it to like an infiltration basin or construct it wetland, the water goes back underground. It's not in the right place. I mean, we could put pipes under the road and move the groundwater back down the hill. It's very expensive. There are permeable road surfaces, again, very expensive. Then the water just keeps following the pathway it should have followed. But at least if we dump it into an infiltration basin, it won't cause flooding and it will go underground. And so we keep our water tables higher. And I do a whole program. My whole bigger program is sustainable water resource management globally. 4 billion people globally have no water on a month by month basis every year. 4 billion. We're throwing away fresh water you can drink out of the sky. Save the rain for a droughty day. Get it into the aquifers and start thinking about how to share our water is what I believe. The second overarching approach is that there are strategies to reduce and filter out the contaminants. And naturally, some of these overlap with flood control, but things like just keeping vegetation in the ditch captures sediment. We've done at least a couple studies that can prove that. So mow the ditches, don't scrape the ditches. Let's get grass growing there. Hydroseed the ditch. Use check dams, slow down the flow so they're not so erosive. And so there are bioswales and various strategies. We've worked through what the costs are for those. Dr. David Orr helped us work through what the costs would be to use alternative strategies, green infrastructure, basically, so to filter out contaminants. Things are still moving slowly. We have been talking about this for 15 years. And it's not happening for me, it's like, there's a solution, let's just do it, but it's not happening as fast as we expected. And so we've started really engaging with decision makers to understand, well, what can we do from the top down? We were very happy when we were successful in getting the Chesapeake Bay program to finally adopt. I mean, I kept talking to them finally, we had a workshop, we started getting people involved, and they did. They adopted roadside ditch management in 2017. Is now an accepted strategy to meet the total maximum daily load requirements for the Chesapeake Bay. That's a major accomplishment. I have a graduate student, Sarah Davis. We started to look at, well, will that happen? How does the Chesapeake Bay work with all these 6 different states? And interestingly, she did a survey. And what we found out is, well, it's not really a well-organized system for doing trans-boundary coordination, which is ditches run across boundaries like streams do. For example, New York State, 69% of the roads are managed by towns. Whereas in Delaware, 89% are managed by the state government and only 11% by town. They have different manuals. There are guidelines many places. They're not mandated. They're not clear what are the best BMPs to use. It's not a hierarchical structure. So we're trying to figure out ways, how do you get everybody to work together? So you might be hearing from Sarah in the coming months. She's going to start doing, as a chapter of her dissertation, talking to town highway staff, sending out surveys about cross boundary, meaning borders between 2 towns. Do you work with the highway guys in the other town? If your ditches start over there, what kind of trans-boundary coordination is there? Now, we honed in on New York State's highway staff because it is one of the states where everybody, really the towns work on their own. It's very much, they manage their own roads. And we put out a survey in 2014. It went out to all 999 town and county superintendents, and we got about a 40% response rate. That's what the map is up there. And what we found is really interesting. Now, first, these town highway guys work really hard. I attended a meeting in Auburn one time in the winter to talk about ditches. And I sat there listening, and they were sitting there talking about the fact there wasn't enough funding, and they had to go out in the middle of the night at 2 a.m. to plow the snow. They couldn't really afford to have the person who was going to keep track of where everybody was, and they were figuring out how to use cell phones so they could make sure they could do their job, clearing the snow out so we can get to work. This is really typical. They're very hardworking. And they're working with, well, we'll continue. Anyway, so we learned some interesting things, though, about the ditches. About 37% of the ones who responded used scraping as their main way of cleaning out the ditches. And they did not think or did not reseed or revegetate. And that's really the main way they were doing it. That's more than a third. They scrape about once every 3 years. So basically, a third of all the 1,000 of highway guys are scraping once every 3 years and not putting any vegetation back in the ditch. New York State has 117,000 miles of town roads being managed like that. with 1/3 to 1/2 of them basically in fair to poor condition because of this kind of practice of scraping. Think how many thousands of miles of sediment are washing into the system. And then the problem of them digging deeper with now soil eroding down into them from the sides. Mr. William Heck was kind enough to send me photographs. He takes these amazing photos of from above of plumes of sediment. This is Cayuga Lake, and ditches are contributing to this. All right, both as conduits from the farm fields and other exposed soils out there, and also when they're scraped. And with the sediment comes phosphorus. So as we think about how to manage phosphorus in our lakes because of like algal blooms, and we now have a proposed TMDL, total maximum daily load rule, has just been proposed for Cayuga Lake, the southern part. This is a piece of the puzzle that we can work on. We asked these highway guys, and it was great. They gave us tons of information. They're delightful to work with. They're super busy. And on the left, I put photographs. They filled the potholes. They scrape the snow. They put the lines down. And ditches are a part of all this stuff they're doing all the time. And not surprisingly, they're working with limited town budgets. So time, labor, equipment, all the resources you need to change practices, they don't have enough. All right, they're already too busy. And that we have to address. If we care about water, we got to make it a priority. Say, look, we want you to be working with water too. You're our water stewards. We're going to give you extra money. It's now part of your mandate. But they listed 2 other barriers to changing behavior. And these are interesting. I'll start with farmers and tiling and just briefly tell you. So the deal is this. Tile drains are these tubes that are put in farm fields about 3 feet underground. And I took all these photos except the one in the lower right. And the point of them is they have holes in them. So when it rains, the water kind of shunts right to the tube in the underground and shunts back out. And so the field stays drier. Now, this is useful because then the farmers can get out earlier in the spring because the soils aren't too soggy to run a tractor on them. The soils don't get too soggy some years when it's real wet and kill all the crops. So it's a way to manage the soil by draining the water out. But historically, the tile drains dump to the roadside ditch. Nobody's ever paid attention to that all that water is now basically, again, increasing the length, the connections between streams and our land use activities with the tile drains. Not relatively, New York has not got a lot of tile drains. The Midwest looks like this lower right-hand corner, and which there are tile drains every 30 to 60 feet apart. And some states have as much as like 60% of the entire state's been tile drained. We're starting to realize that might be problematic out there. But now tile drains are being adopted across New York State because they're so easy to put in. It takes like in a day, you can get more than 500 feet, quarter mile in. These are the tubes being laid out in this farm field. And that was all put in about 3 days. So the tile drains are an opportunity to me. Or the more the problem, if you spread fertilizers and pesticides or manure right on the soil, on top of the tile drain, right over here, that means there's only 3 feet of dirt separating whatever you spread up there till it gets to that tube, shunted to the ditch and down to the stream. Rapid movement. This is an opportunity. If we even just say don't spread manure on top of it, keep it sideways, it won't end up as quickly in the tube. It's not managed. We're not managing tile drains. Vermont is way ahead of us and has done a lot of homework on what are the different options and what's the evidence. So more can be done with tile drains. Okay, this is where we shift to what some of the things we're doing right now and some new approaches in the last part of the talk. So one of the barriers the highway guys pointed out to us was private landowners, because private landowners in towns own to the center of the road throughout New York State. That 117,000 miles, people own that right to the center, and there's what's called the right-of-way. It's a public-private interface. It's fascinating. And the highway guy said, look, we don't want to upset the owners of the land by widening the ditch so we can mow it. You know, that might upset them. And, you know, I'm an elected official. And we said, well, where's the data on that? Is that true? So we did a pilot, and this is Kalina. She's been working with us she's an undergrad honors student doing an amazing job. We did a pilot survey of Justin Tompkins County in 2019 to ask landowners, what do you know about your right of way? What do you think about your ditches? What we found out is most people don't have a clue how wide the right of way is, what it is, who owns it. They're not sure who's supposed to manage it. 82% of them go in their ditches. They interact with their ditches, mainly to pick up trash, but many mow, a few garden. 50% of them never think about the ditch water and where it goes. That's no surprise. That's what we've been dealing with. People don't think about ditches. But 78% were willing to reduce fertilizers and pesticides on their lawn if it would stop polluting once they realized, oh, these connections exist. 55% never met their highway guy, don't know anything about them, but they were glad they were doing the maintenance in the ditch. So there's this disconnect, but an opportunity. And 50% reported they would be willing to accept an increase in their taxes or widen the ditch into their property to reduce pollution. This is just a pilot, and it's Tompkins County where we've been talking about ditches for so long that I think people are kind of aware. So it's a bias, and there's Cornell there and Ithaca College. It's a biased sample. And we now have a small amount of funding to do this same survey across the state. But for me, it opens up a whole new way to tackle the stakeholders, because if we get people educated about this and they say, hey, highway guys, we love what you're doing, but we don't want you polluting the water, suddenly they're the people, the private people, land owners are the ones electing the highway guys. And we can tackle this problem from a very different dimension. A second big thing we've been doing is that issue of nitrogen moving through the ditches. Well, there's this strategy being used out in the Midwest called wood chip bioreactors. They dig a hole the size of a room, they fill it with wood chips from a tree that's ground up, and they direct all the runoff from the farm field into the pit. And what happens is it denitrifies, that microbial process I told you about, and takes out all the nitrate out west. And we said, well, wait, maybe we could scale these wood chip bioreactors down, way down, not the size of a giant room, just the size of a twin bed mattress, and put one in a ditch, and maybe it would take out some nitrate. So working with some graduate students and now the Pennsylvania Center for Dirt and Gravel Roads, we designed one, studied it for a couple years, and then it worked. Doesn't work all the time. It works really well sometimes, and then other times not at all. And we said, well, what if we could put two in a row? And so that's what we've been doing with Eric Chase at the Pennsylvania Center for Dirt and Gravel Roads. And this is what I'm showing you is, this is the water depth in the ditch. There are two of these socks right next to each other. And on the bottom, what you're seeing is what the nitrate concentration is in the ditch water before it goes through the first sock, after it comes out, and after it comes out the next one. And what you see is sometimes we get 100% of the nitrate removal. Sometimes not much, 1%. And when there's a lot of flow in the stream, in the ditch, we don't get any. Sometimes we get 25%. But having two in a row remove more nitrate. It's not a silver bullet. It's just, oh, okay. They only cost like $100 to make. They're nothing. It's dirt cheap, and they took us an hour to put one in. It's basically work free. And there are caveats. If you have a ton of sediment moving in the ditch, it will clog up the sock, and then the water will go over top. So in places where there's high sediment, not the best strategy. But they're really easy. And that the beauty is you can just drive up next to the ditch, right, with a truck and do these things. One more piece to this. I started working with a student who has family in Indonesia, and actually along the Bengawan Solo River in Java, Indonesia. Turns out this is the second leading river in the world as a source of plastic trash to the world's oceans, on the order of hundreds of metric tons per year. Jakarta's there. If you know anything about plastics, Southeast Asia is the main place where trash is coming from. And I said, look, maybe we could look at ditches over there. Maybe that's a mechanism. So she's been using Google Earth Pro during the COVID years and mapping out ditches. And sure enough, in these, we looked at 30.3 kilometer square plots. And there's what one ditch looks like. They're like kind of, some places are open like ours are out. And then some places they're like these concrete channels with dirt on the bottom. And sure enough, the ditches basically increase the stream length by threefold, just like we find here. Most of the ditches dumped it straight to the streams. There's a lot of trash. We can't always see what's in there on Google Earth Pro, but sure enough, there's the trash piling up. So that's exciting. Again, it's a tool. And so my mind is all around using roadside ditch networks as a basis for watershed-wide filtration systems, where you can drive up to them. You can put a couple of these socks in. There might be ways to add calcium that would help affect acidity runoff, your acid mine drainage. And in Australia, they're actually putting these bags to capture the trash. So we could actually think about adding this as another piece of this filtration system to catch trash and plastics. And so more can be done. Ditches are so easy to access. I don't think it's not the overarching answer. We have to work with the whole landscape. We have to get rid of greenhouse gas emissions, but they're a piece of the puzzle. Just so you know, roads are everywhere. And everywhere there are roads, you'll see a yellow dotted line down the middle, and you'll see a ditch on each side. There's Ethiopia. The average road density around the world is 1.5 kilometers per square kilometer. In the US, 50% of the US is within about 700 feet of a road. So this mindset of, look, we can apply this everywhere. We can start thinking about the ditch networks as a filtration system that we can use to our benefit. One highway superintendent wrote this down. With the increase of the amount of rainfall per storm in recent years, it's hard to manage the amount of water entering the ditches, which contributes then to larger ditches and flooding. It's a huge issue, these increasing storms. So I'll stop there. I love this picture. It's a global strike for climate change. 1.5 million students walk out of class demanding action. Be part of the solution, not the pollution. And so these are really important issues that we need to deal with. I will stop there and stop my screen sharing. Yeah, you can do that. And answer anybody's questions.
Thanks so much, Rebecca. That was fascinating.
Okay, great.
I think just so everybody knows, the chat is available for you to put your questions, and then we can kind of go through them. We did have one that came in earlier in the talk where one of the people watching asked, what dissolved chemicals are you testing for? And if you measure sodium and chloride.
Okay. All right. So it depends on, we get funding for a project. And like, for example, when we did the fecal coliforms, that was very specifically funded just to look at the microbial contaminant. So we've done the nitrogen one. We periodically, like we have one study where we have a lot of information about de-icers, sodium chloride. And sure enough, in spring, we got a ton of calcium, magnesium, and sodium moving through. Like, oh, there it is. There's the de-icer peak coming through. It's a huge issue because many of our rivers and our groundwater have become so salty that they're becoming unhealthy for salamanders and organisms. They're not drinkable. And sure enough, the ditches being right next to the roads are a way for those salts to move. Now, note, nobody talks about it, but we also use salt to take care of water softeners. So I have super hard water in our house. All right. I mean, so hard it forms lime crust. And normally people buy a water softener, which is a plastic resin bead that takes the salt out, but you have to periodically pour bags of salt into the water softener. And that goes into our whole system too. So there are other sources of salts that are contributing to the problem, but de-icers are a part of it. When you talk to highway guys, they'll say, we definitely use more salt than we used to. But nobody, when I grew up, we put chains on the car and you drove slowly. People don't do that anymore. I mean, they want to keep driving the same pace. So they're using more salt and more sand because that's what society says they want.
Great. Do you know, somebody's wondering if you know if there are places to get easy testing for E. coli coming down ditches?
Easy testing. There are labs across New York State that will do that. I mean, and they have, we had a really cool, simple method. You put it in and it's a plate and you just incubate like a small amount of water overnight and in a heater, like a warm oven. And then you put it under a black light, I believe it was. And I think Kim's online, she could probably tell you more about it, but there are simple methods. Who does them? You'd have to check different labs. I know we work with Freshwater Institute up near Syracuse, I think it's called UPI, Upstate Freshwater Institute. They do that. You'd have to look to see who's actually doing it.
Great. Here is one about the ditches. On average, what % of sediment and nutrients reaching lakes and rivers originates from the ditches? Okay. And then that might obviously shift regionally, but.
Totally. All right. The only estimate we've done of that, and I worked with Kim on her when we did that, we looked at 3 storms and where we knew how much sediment was moving into the Susquehanna out of the New York State. And we calculated how many roads were probably scraped and our rates of sediment coming off of those roads. And that kind of rough estimate came to about 10% of all the sediment in the Susquehanna River on those storms, those 3 storms, came from the scraped ditches. All right. And it was just a rough kind of, here's all the miles of roads, and here's how much sediment's in the river, and here's how much we would calculate we're coming based on what fraction would be scraped. But it was 10%. So we haven't done any other kind of analysis to see what percent of sediment is just from ditches. That's the only one we've done.
Here's a kind of a similar question. Is there a good understanding which streams have less water due to interception by ditches versus which have unnaturally high flows from?
Let me tell you, I am so fascinated by this. The way I figured out is I was using U.S. Geological Survey topographic maps, and they're online. But I'm old enough that we had tons of paper copies, like they come in 1950, 1976, and they update them 1984. And we start looking at a sequence of them, and we're trying to figure out which streams are, we want to work on a first order stream, which means it was permanent. And we would watch as streams on the map went from being solid blue lines to dashed lines more and more and more over 15-year periods. And that's when I thought, oh, they're drying up. They're getting impermanent. Is it climate or is it development? And then when we saw the phenomena we saw where that one road captures so much water and shunts it away that the streams are dry. So what percentage of all the streams have been affected this way? I don't know, but I think it's a lot. I mean, there's roads everywhere.
Yeah, great. Shifting a little bit to highway workers, we have a question about how do you encourage overworked highway workers to, learn and to watch some of these, roads programs?
Okay. So I think personally, we need an entire revamping of how we think of highway guys. So people kind of think of them as janitors. They're out there doing that work. We need to market them as water stewards. They're our watershed stewards, water stewards. They're the ones who do the plumbing. And so we need almost like a publicity campaign with billboards saying, get to know your highway guys. They're also your water guys, rethink what their roles. That means they need more money because now they have to have an explicit mandate that says, you're not just doing roads, you're also doing our water. That means you need more resources. You need more training. You need some people who are trained in the water aspects of what they do. I mean, they're the ones who come out when there's flood events, and bridges wash out. There are emergency teams. They need to be rethought about what their role in our landscape is. Not just, they kind of clean the roads and keep them going. It's just a whole different mindset about what their role is and the resources they need. So they'll have time to take the trainings. It's a total rethinking of the entire system. They've been left out of this conversation for 100 years, and they kind of default to doing what was done, digging another ditch. And it has to change the whole thinking about what their role in all of this is. They're the ones that are doing the hands-on.
In addition to the town highway guys, have you spent any time with the New York State DOT or like county highway super?
Right. So we definitely worked some with New York State DOT, and his mind, I just had a senior moment. Mark, it's gone from my mind, is in charge of the drainage committee, and we've given him our PowerPoints and slides and fact sheets, and he works training some of the county people. He kind of says thus far everybody's real busy, and already has plenty to do, and without incentives and kind of, this is the way we do it. When are we supposed to switch and do all that other stuff? Why should we? This is a ship that's been going the same way for 100 years, a giant tanker, and we're trying to turn it. It's happening. It's definitely happening, but it's just very slow. So haven't gotten to the county level as much as I want. And I'm starting to try and work with soil and water conservation districts, like for the tiling issue. They help kind of do the tiling. So there's for sure some audiences we have not reached as effectively as we need to.
See, this is a really great one, I think. What can individual homeowners do?
Private landowners.
Came from somebody who lives at the top of a hill in the upper Susquehanna watershed.
So get to know show you care about the topic. All right. We'll send you fact sheets, get more informed about it. Think about where your ditch goes. Start kind of looking where it's going. Get to know your highway guys and say, hey, listen, I want to mow my ditch. I want to garden in it. Don't make it really deep. All right. And they need to start hearing that people do care about what's happening in the ditch. Okay. It's really an education campaign to the private landowners, and we technically own that land. It's a public-private interface. So Again, we just did that one survey, but we're so encouraged, like for 50% to say we'd pay 1% more taxes just so they wouldn't pollute things, or I would let them widen my ditch 2 to 3 feet or more just so they could mow it. That is really encouraging. So I think getting involved in the conversation with your highway guys, you're paying him. I mean, he works for you. Talk to him about ditches, and say, hey, are there other ways we can do this so we're not polluting and causing flooding and cars are getting stuck in ditches because they're so deep? They're safety hazards. So we found that if the ditch was less than 3 feet deep, there was a significant increase in people's engagement, mowing the ditch, gardening the ditch. But and they only need to be 1.5 feet deep. They're making them 3 feet, more than 3 feet, 4 feet, 5 feet deep. That's not the right answer.
We have a question about the Cuba Lake TMDL, and just wondering if it will force local communities to find resources to implement better ditch management.
Force them to find the resources. I haven't read it. It came out yesterday, and I will review it. And I know there's a section in the appendix about ditches. Force them to. It'll encourage them to. I don't know how the TMDL is a regulation, so it does somewhere have monitoring and that and enforcement. In theory, that feeds back to how towns and the city behave. It would be great if it got people to start thinking more about, oh, these are easy strategies. We can do things to reduce. Like I said, ditches are easy, guys. You drive up next to them, divert a ditch into a basin. That stops the whole problem. You just scrape out the basin, take the sediment out periodically. They're an easy part to this. So I hope it does encourage people, but I haven't read the wording. I don't know enough about what they said to say what the right response is.
Rebecca, do you know if berms and swales are an alternative to tiling in farm fields, and if they're have been proven effective at all?
Berms and swales. All right, let me think. Out west, I know there. All right. First of all, one good strategy would be stop directing them to the ditch. I mean, if you just took all the tiling and left it on the farm and directed it to like a pond, right? All the water would go underground and everything would stay there and not go to the ditch. So, and it's just, this is what everybody does. It takes them straight to the roadside ditches. They don't have to think about it. But so one strategy is redirect the tile drains. Out west, they are definitely doing some things with like some control structures at the end of the tube. So like during a big rain event, they clog it off, let the water build up, and then slowly release it. So it's not going straight to the river. All right. So there are control structures they can use on some of the tile drains. I haven't heard about the berm, so I can't quite visualize how they're using that. Bioswales are a great strategy within ditches for dealing with, water and filtration and slowing water down. But I have to see how that would work in the context of a tile drain.
For some of the wood chip bags that you have developed, do you know how road salt impacts those? Does it like reduce their effectiveness?
Great question. We haven't looked at that yet. We were really focused on dissolved organic carbon because I was worried about the wood chips leaching carbon out because that could pollute. That could actually suck down the oxygen, the bacteria chew it up in the streams and could affect the stream. So we really were paying attention to the wood chips themselves. But they're not a problem. So the DOC is not a problem, dissolved organic carbon. But we haven't explicitly looked at what the salts do. They may, if it gets salty enough, I don't know if denitrification, how well it works. I think one study by Dr. Todd Walter at Cornell and his grad students showed it didn't affect denitrification in some stormwater basins. So I don't know for sure with the wood chips. I could look in the literature. Probably some people have done some stuff out west, but that's all I know so far.
Great. This one actually is for Andy, I think. And this is about the Van Riper, our Van Riper Nature Preserve. And would building an impoundment at the Van Riper Preserve help solve the erosion problem there? And I know that we're the erosion problem there.
For folks who aren't familiar, we own a preserve on the west side of Cayuga Lake that has about 1,900 feet of shoreline, but it also has a very small borderline perennial stream that goes under a section of Route 89 that was really radically changed in the 70s. And it's been down cutting. It's had a severe erosion problem. So we're in consultations with U.S. Fish and Wildlife and the Seneca County Soil and Water District and looking at reducing the erosion. We did look at originally at a basin, but we found it would have to be on the west side of Route 89. It would have to be so large in size based on the watershed and given the terrain, it didn't seem feasible. So that was actually the first thing we looked at. But given the particular characteristics of the site and how large it would be, we didn't think it was an option.
Rebecca, this one's back to you. Do you know if highway departments have any authority over what gets discharged into the ditches by the adjacent property owners?
No, I have not seen any examples where they do. The
Okay.
reason they raised it in the survey as a concern is they said they're not told when tile drains are put in place. The farmers don't alert them. They just suddenly start realizing they're having a flooding problem or an erosion problem down in the ditches, and they trace it back to new tiling. So I'm not aware. Nobody's ever said, "Oh, I get to influence what's being brought into the ditch."
Great. And I have one more. Do you know of any way that the roads themselves, other than I guess the permeable roads that you mentioned before, could be redesigned or reconstructed to help alleviate the situation or reduce the reliance on ditches?
All right. So right now, the Center for Pennsylvania Center for Dirt and Gravel Roads is freaking amazing. It's a team of about 6 guys with Steve Blosser in charge, and they've been working together as a team for 15 years. They go all over the state and they work with towns. They have a training the towns take and a 1-page proposal, and then they go design their structures, and they are doing a great job with ditch management. They have put in tubes under the road at frequent intervals. So when the water comes down the hill, it's diverted into the tubes and goes under the road and comes back down and keeps them going down the hill. It's not cheap, but it's a strategy to keep the water moving downhill instead of being intercepted by the ditch. They have put in several roads. They call them a French mattress, a coarse rock underbedding to the road itself, so that the water comes down, it hits and goes under the road through these coarse rocks. They could tell you more about that. There are permeable asphalts that the water can go through. They're very expensive, and they can't get dust in them because that clogs it up. So they vacuum those roads, which is really crazy. So there are other ways then to keep the water moving through instead of being captured and shunted away. Again, I'm not an engineer. I'm actually an ecologist. So as we get into the nuances of the engineering, we'd have to get other people involved to really tell you, all right, square footage of asphalt and pipe and all that. But yes, there are some others. I think the pipes under the road might be the simplest thing. If they go down into a field, I mean, if you have it running into somebody's yard, they might start to gully and cause some problems there.
Great. I did want to point out, a few people have mentioned in the chat that the Community Science Institute in Ithaca will test for E. coli. So
Cool.
if that's something that people in Ithaca are interested in doing, that's a place or a resource.
They're very nice people. I've talked to them several times, and they're very much about community support.
Yeah, so that is great. I think I hit most of the questions here. I will, just so everybody knows, I know there's a few people also shared contact information from different highway superintendents who are getting in touch with you, Rebecca. So I will share the chat comments with you.
That would be great.
Have that information.
That would be great. In fact, as we're trying to start looking at this cross-border collaboration, we're using it as a model for what's happening globally with cross-border water management. We want to see how people interact with their neighbors about, when the water's coming through. So I'd love anybody who's interested in working with us on that. That'd be great.
Yeah, great. So I'll share that. And one last question that I see here is, are there sweeping requirements for municipalities to protect water quality? Like, are there some general?
I don't know. I'm sure David Orr knows, and I can ask him. I'm sure he knows. I don't know that. All right, that's getting outside of my bailiwick. Road management. I mean, he knows everything about road management, but I know we could find out.
All right, great. Well, Andy, I don't know if you have any last thoughts.
I would just thank you, Rebecca, so much. This was a great program, and I always learn from you. And we hope to, keep at this because, as Rebecca mentioned, we can do things here. We can make improvements, and it's an opportunity. So we look forward to working with everyone on this, and we also look forward to doing more programs like this. So thank you all for coming out tonight.
And really, my thanks to the Finger Lakes Land Trust. It's really that land protection. The bigger watershed, I'm just a little piece of ditches. We've got to protect more of the forested lands and just the open space to accomplish these things. So it's a team effort.
Well, thank you so much, Rebecca. And thanks everybody who's on the call for coming out tonight and learning a little bit with us.
Great. Thank you.
Have a great,
Thanks,
oh, also,
everybody.
we recorded this presentation and I will post the recording. So if you want to watch it again or share it with somebody, it will be up and I'll try to send an email out with that link at some point in the next few days.